Hello everyone. In this video, we'll understand about handling I/O operations in C. The input-output functions in C are built around the concept of set of standard data streams. Now these data streams are connected from each program to a basic I/O devices like keyboard and monitor. Streams can be defined as a sequence of data elements that are made available over a period of time. Now there are three data streams. They are standard input, standard output and standard error. Also, C provides several functions that give different levels of input and output capability. These functions are implemented as routines, right? They call lower level input and output functions. The standard streams are files which are opened by the operating systems and are made available to every C program for use without having to open or close these files. They are the standard input, standard output and standard error. Now, as shown in the figure, the standard input stream is connected from keyboard to the program. The standard output is connected from the program to the display. The standard error is again connected from the program to the display. So, when a user enters any key from the keyboard, it goes to the stream, that is standard in, and from the standard input it goes to the program. Similarly, when the program displays something, it first goes to the standard output, and from the standard output the data is to the display. Same thing happens with the error too. There are number of functions and macros which helps to operate these streams. These macros or functions in C programming are declared in a header file called stdio.h. stdio stands for standard input output .h is a header file, right? The input output functions can be classified into non-formatted input output functions and formatted input output functions. The non-formatted input output functions provide the basic and efficient form of I/O, and they provide with a compact way to store or to print the data. However, these functions deal with only sequence of characters, that is, any data is entered, it will be treated as only characters. No matter you enter even 1, 2, 3, 4, it will be treated as characters and will be stored into the memory. The non-formatted input output functions in C are getChar, putChar in order to read a character from the console and to put one character onto the console. If at all we want to read a group of characters or to print group of characters, we make use of getS and putS function. Apart from this, in Turbo C compiler, we have a variant of these functions as getCh and putCh to read a character or to display a character onto the monitor. This slide describes the examples of getChar and putChar. So, getChar, it returns a character that is entered by the user which is stored into a character variable. If at all I want to display that particular character, I need to pass it to a putChar function, and this basically displays a character. If at all I want to read a string, I declare a character array. I read it using getS, print the same string using putS. So absolutely there is no format. Everything is treated as a group of characters or a single character. The other type of functions are formatted input and output functions. These functions basically convert the stream of characters into an alternative view. It could be integer or floating point numbers. There are two functions, one is printf, the other one is scanf, and these are basically used to format the input and output data in C. Scanf reads the stream of data entered by the user and converts it into a specific format, and it can accept data of any of your choice, any types. Printf prints the data of different type on the console in a specified format. Now, if we look at the difference between a formatted and unformatted input-output statements, in case of formatted input, the supply of the data is in a user format, it is in the desired format, whereas in case of unformatted input-output, it is only in terms of character or stream of characters. These formatted functions, they contain something called as format specifier. We'll be shortly discussing them. And unformatted, they do not contain any specific format specifiers. Here the data is stored in a user-friendly manner, integers separately, floating points separately, characters separately, and so on. Here the data is stored more compactly, right, because everything is in terms of characters. It can be used with all data types. It can be used efficiently only with characters and strings. Examples include printf and scanf, getChar, putChar, getS, putS, etc. Right? Now we'll just have a look at the non-formatted, formatted functions and the general format. So printf, the general format of printf is printf control string followed by the list of variables. Okay, this control string, it can have any or all of these three objects, which is made up of ordinary characters, conversion specifier field, or it can have a control code. Now what do you mean by ordinary characters? We have something like this: printf hello world. I want to display this on my screen. So these are nothing but the ordinary characters. These will be copied as they are onto your screen. The second type of objects are the conversion specifier field, wherein I specify a specific format. Now, if at all you have it, you precede it with a special symbol which is called as a percentile symbol. Followed by it, there are a conversion codes, the optional modifiers like width, precision, flag, and size. We'll see with these things in detail. The last one is the control code. This includes the optional control characters like \n, \b, \t, \v, etc. These are also called as escape characters. Escape characters or control sequences. Now, we'll just have a look at the conversion specifier field. The conversion specifier field, if at all it is there in the control string, the format of it is as follows. So you have percentile symbol, followed by it compulsory a conversion code, okay, a conversion code. Then you have optional size, precision, width, and a flag. Now, what are these conversion codes? These basically indicate which type of data I want to print or I want to read. Okay, so the various conversion codes are C for characters, D or I for integers, E for representing a number in an exponential format, F for floating point number, G again float or double, O for octal number, P for pointer, S for string, U for unsigned decimal number, X for hexadecimal number. If at all I want to print only a percentile symbol, I make use of percentile, okay, and percentile n is used for pointer to integer. Okay, so these are the conversion codes that are used in a printf as well as for the scanf. So we have in a control string a percentile followed by one of the conversion codes. Okay, so it could be C, it could be D, it could be F, G, and so on. Apart from this, we have optional size modifier like H for short integer, L for long integer, and L, capital case L, for long double. Okay, we do have precision, that is again an optional specifier which indicates the number of digits to be printed after a decimal point. For example, I have something like this: pi is equal to 3.142. Now if I use a printf statement, printf percentage f pi, by default this statement will print 6 decimal digits after a decimal point. Now if I want to restrict to only 2 places after a decimal point, I have to specify a precision field. So how do I do that? I will rewrite this as printf percentage point to f pi. So this will print only 2 decimal digits after a decimal point. The value will be 3.14. So this is an optional modifier that can be specified in a printf statement. Minimum width, this is used to specify a minimum number of positions that the output will take. For example, I can restrict my output to 10 character spaces. I can specify the width to be 10. Okay, so if at all I have the printf statements something like this: printf percentage 10f of some d. So it means I am reserving 10 character spaces for my output. Remember, this is a minimum width. If at all your data is more than what is specified as a minimum width, then this is not taken into consideration by your printf statement. The next one is flag. So flag has three types of control. One is justification, padding, and sign. By default, the data is filled as right justified. I will shortly come back with this. If at all you want to make it left justified, the output to be left justified, we need to specify a hyphen in my printf statement. If at all you are having a right justification, okay, and you can fill the empty spaces with zeros, you need to mention it as 0. Sign, by default positive numbers are displayed without sign and negative numbers are displayed with sign. However, if at all you want to display a number with its sign, then you need to precede it with plus. Okay, we'll just have a look at the example. So here we have number is equal to, so the output will be, I have specified here a minimum width of 3. So as I told you before, the output will be right justified. That means you will start filling the number from the right. So this will be the output. For the second one, the output will be something like this: number is equal to, minimum width is 2, start filling it from the right. This is called as the right justification. Now if at all the minimum width is very less, then how will the output look like? Right? It will be something like this. It will display the number with as much of space that is required. Now what about this? When minimum width and the precision is specified, how will the output look like? You will have number is equal to minimum width is 7. Start filling the number from the right. However, the precision is 0.2. That means you need to have 2 digits after a decimal point. So it will be 34.5. This will be the output. Okay. However, if this number would have been more than 5, then rounding would have taken place. We'll see with this example. You will have something like this. So you have number, I have not specified any width over here, so the output will be 5.44, right? What about this? When the precision is more, I will have number is equal to, I will have something like this, 5.4321 followed by, correct, 4 plus 9. Okay. The last one, number is equal to, by default printf statement will print 6 decimal digits after a decimal point. Okay. So the same thing is put in terms of boxes. Okay. Yeah. When other modifiers are specified, like flag, as I told you before, flag is used to control justification. It is used to control padding, and it is used to control sign. Justification, by default it is right. If at all you want to have a left justification, then you need to specify a hyphen. Padding, whenever you have a right justification, you need to fill the empty spaces with 0. We make use of padding. And sign, if at all we have a plus sign, it means you will be displaying a positive number with its sign. Okay. There is no hard and fast rule you have to specify in this order only. The order might differ. For example, you might specify sign first, then padding, and then justification, or justification, sign and padding. Any order the specifier could be specified. For example, I have 0, 6.1 f. So as it indicates, 6 is the minimum width, 0.1 is the precision. Here 0, it means we are making use of padding. So how will the output look like? You will have number is equal to, you will have 1, 2, 3, 4, 5, 6. So the output will be 5. You will have 5.5. Since 0 is there, which means it should be filled with 0. Okay. The second one, you have minus, which means it is for your justification, plus is for sign. Okay. 6 is minimum width, printf is for precision. So how will the output look like now? You will have minus, it means left justification, plus is for specifying the sign. So I will have something like this, plus, okay, I will have 5.5 is equal to number. Okay. The last one, when I specify minus again here, it means it is a left justification. So numbers will, the data will be filled from the left onwards. So I will have 17.235. As you can see here, there is a rounding happening at this particular digit. Why? Because the very next digit is greater than 5. Right? Yeah. So this was all with respect to your printf statement. The next one is scanf. Now scanf is called as an input formatting function. You will be reading the input using scanf. So I have scanf followed by optional character string. You can have ordinary characters as a part of your scanf, but however the restriction is that whenever you are specifying the input, it should match with this character string. So most of the time we avoid having this character string as a part of our scanf. Followed by it, there can be a conversion specifier field, as we have in printf specifier field, conversion specifier field, we do have it in our scanf. This is followed by a variable list, but however we just don't specify the variable name, they are preceded with this and operator, we call it as ampersand. Okay, so scanf is used to store values in a memory locations associated with variables. Okay, scanf uses variable addresses rather than just a name. Okay, so as discussed, the character string is optional. Okay, but however we have to specify a conversion specifier field. Now what is the format for it? We have only one flag, that is assignment suppression flag, followed by width, size modifier and conversion codes. We'll just have a look at them. The flag, that is star, it is called as an assignment suppression character. If at all we want to read a value but do not want to store it anywhere, we make use of this flag. For example, I have something like this: scanf %d %c %d. Okay, I will store the values into date, comma, month. Okay, now if the user enters 21-5, here 21 is stored into your date, 5 is stored into your month, 5 is stored into your month. However, this character is read, but it is not stored anywhere because it was suppressed using this assignment suppression operator or character. Right? Here width designates the maximum number of characters. In case of printf it was minimum, but in case of scanf it is maximum number of characters that are to be read. For example, I have something like this: scanf %10c, which means your c ampersand c, which means your scanf will stop reading after 10 characters. So 10 here, it means maximum number of characters to be read. Now the main differences between scanf and printf is, here in case of scanf we will not specify the conversion codes, we will not specify the precision in the conversion code. If at all we specify, the scanf stops reading the input. The second one is, there is only one flag which is called as assignment suppression flag. In case of printf, the width specification is maximum. In case of scanf, it is minimum. Okay. Apart from it, the scanf supports something called as scan set characters, wherein you can make a scanf to read a particular pattern. If at all used, you specify these scan set characters in a square brackets. Okay. Now, when scanf process scan set, it will process only those characters which are a part of scan set. And remember, these characters specified in a scan set are case sensitive. They are case sensitive. Okay, let us have a look at few examples. Now, I want to read only uppercase letters. I will specify a scan set character as this percentage. In a square bracket, I mention A to Z. So this will force the scanf to read only a capital case letter of a entered string. The second one, if at all I want to read, I want to stop reading once I reach O as a character, I can make use of a caret symbol followed by O. This tells the scanf statement to stop reading once it has encountered O. Similarly, if at all I want to stop reading once I encounter a new line, right, once I hit an enter button, my scanf should stop. I make use of this scan set character, right. So by this we force a scanf to read a particular pattern. So that's all in this video. Thank you.